Welcome to Leetcode JavaScript, a channel where we solve every single Leetcode question using JavaScript. Today we have 2131, longest palindrome by concatenated two-letter words. This is a medium question. So let's begin. You're given an array of strings words. Each element of words consists of two lowercase English letters. You have to create the longest possible palindrome by selecting some elements from words and concatenate them in any order. Each element can be selected at most once, and we have to return the length of the longest palindrome that you can create. If it is impossible to create any palindrome, return 0 instead. A palindrome is a string that reads the same forwards and backwards. Let's take a look at a couple examples to understand this problem better. So we have these lists of words, and the longest palindrome you can probably realize very quickly by yourself is LC, GG, and CL. And as you can see, you can read this forwards or backwards, and it's going to be the same. And the length of this is 6, so that's what we return. Now, this problem may seem a bit tricky, but actually there's a clever solution I would like to share with you that makes this problem remarkably simple. So we can use either a hash table or a 2D array. I like using 2D arrays for problems that are a string based, because you can take advantage of the fact that every single character has a character code. You can take advantage of that and make the solution cleaner. So I believe the solution is super clean, so let's start. And I'm gonna start by creating a count array of length 26, and I'm gonna fill it with 0. But actually I need to do this as a 2D array. So the way we do that in JavaScript is using the map function. And map requires a function inside of it, and we're just gonna do new array 26 that's fill 0. So what are we doing? We're creating initially an array of length 26 and filling with 0. But then we're using the map function such that we have 26 rows of that and 26 columns. So what is this? This is a 2D array of 26 by 26 containing all zeros initially. So we're also going to have to initialize our answer to 0. And there are two cases that we're concerned with, and we're going to do them one by one. The first case is whenever we have a mirror string like LC and CL. And we know for sure if we have the corresponding mirror, we can add those to a palindrome and it's going to be valid. So whenever we find a mirror, we're going to add 4 to an answer. Why is that? Because 2 plus 2 is 4. And be aware that sometimes we may have strings that are the same character twice, and they are considered mirrors. Yes, however, there's a special case. What happens if we only have one of this, or an odd number of this, for example 3 or 5? Well, they can still be useful, because even if, let's say we have 2 extra GGs, we can add those, but that does not mean we need to exclude this one, because since the 2 characters are the same, we could just add it right in the middle, and that's gonna add 2 to our length. So first we're gonna do the mirror numbers, and then we're gonna do the checking for whether we have a singular string with 2 exact characters. So to do the mirror characters, we're gonna do a for each loop. I like to do it this way. So for let s of words, s being a string containing words, and we're gonna do let a is gonna be that s, the char code at 0, and this char code could be a number that's kind of large. I'm not mistaken, something like 97 or 105. I don't really remember it, but I don't have to. Why? Because I can do this minus a the char code at 0. So let's say we have a, for example, and we're gonna do minus a, and that's gonna be 0 for a, 1 for b, 2 for c, and so on and so forth. So we can just store it in an array with no problem. We're gonna be doing this twice, once for char code at 0, then on 1, because we are guaranteed to have a length of 2. So that's quite simple. Now we're concerned with count AB. We want to make sure we know we've seen it, so we're going to do count AB++, but we're also concerned with something called count BA, that it's going to be the mirror number, so to say. So actually we want to check if we've seen it before, and the way to do it is doing it if it is greater than 0, because we're doing plus plus every single time. Then answer is going to be plus equals 4, and count BA minus minus, just so if we're ever encounter with an odd number, we don't mistakenly repeat it twice. And just to make sure we only counter the first occurrence, or rather every odd occurrence, we do it else in this case. And this is relatively simple. This is the for each loop for mirror numbers. But now, as I explained before, we do have an extra case that we're concerned with. It's whether we have a single double character string. And a way to check this is just to iterate through a whole array. So we're going to do for I lit. It's going to be equal to 0, I less than 26, because we're going to iterate through count, and I++, a regular for loop. And if count I, meaning if we have some word that has exactly two characters that are the same. So if that is greater than 0, then we're going to do ands plus equal to, and we're going to break this for loop. Because this has only have one occurrence, maybe we have 4 or 5 that are two characters, but that just doesn't work because we can only use once, and otherwise it wouldn't be a palindrome anymore. So finally, we're going to return the answer, and let's try running this code. And it is accepted. Let's try submitting it. And it works. It's quite a fast solution. It's faster than 93% of JavaScript online solutions, and it uses also a very low amount of memory. This is probably the most optimal solution with a time complexity of O of n and a space complexity that is, well, the additional space is this count, which technically you could see as constant, but we can also consider it to be O n squared because we are using it to the array. But in any case, let's just repeat what we did once again so we're super clear what we do. Given this to the array, we assign every single character code to a space in this to the array. That way we can know whether we have mirror characters. And then we add 4 to an answer. And we have one edge case is what happens if you have one word that has 2 of the same characters but it doesn't have any matching? No problem. We just add 2 to the answer in that case. And that's it for today. Thank you very much for watching. Don't forget to like and subscribe.